Hello, YouTube. This is Umozo3. In the previous lesson, we had another chance to look at pass by value, which is basically this phenomenon where Python passes information by value. So it makes a copy of a variable rather than sticking in the literal reference to the variable itself. And so that can lead to some unexpected results. And we talked in the previous two videos about three approaches that we have in order to combat that confusing phenomenon where a variable doesn't get updated even though we want it to be, for example. So I have three function reference variables, one lambda function, and then one variable, right? My hex equals hex, my character equals CHR, and my ASCII equals OR. So again, hex of x accepts a number like an integer or float and returns the hexadecimal representation of it. And then CHR of x accepts an ASCII character encoding and returns the character with that particular encoding. And then OR of x accepts, it's the opposite. So it accepts a character and returns the ASCII character encoding. And then we also talked about this zip generator. We talked about it in lesson 69 and reviewed it in 70, but didn't review it so much in the previous video. So I wanted to come back to it in this video. And then we have my val equals 4. So my val equals 4. And then class pass by values. This is going to be a pretty short class, only about 6 methods, and they're all very short. So we can talk about it real quick, but class pass by value. So the constructor just accepts one input, and so it says self.myval equals p. And remember with these double underscores, one of the things we talked about in lesson 40, so long, quite a while ago, is that this would be a strongly private instance variable. So you wouldn't be able to call, my val in a particular instance of the pass by value class outside of the pass by value class unless you had a property, right? We talked about properties, and then we also talked about setter methods. But here we have a property method, and we say define my val of burger, right? But burger is not an input here at the point. Remember, we usually say self for instance methods, but here it's just showing you that you don't have to say self. But here we'll get a Python enhancement proposal saying usually the first parameter of a method is named self, right? For instance method. You could just say return burger.myval. So that would just give you the value of the instance variable. And this is how you get around not being able to use a private instance variable. So hopefully that's clear to you. I'm not sure why all that stuff started highlighting in yellow, but hopefully that won't be an issue for us. And then we're going to have we have this loser increment method. Okay, and we're still in the pass by value class. We have the constructor, and then we have this property method which gives us access to the private instance variable. And then we have a loser increment. So loser increment of p plus equals 1. So presumably we want p to be incremented, from its current value to 1 higher, but there's going to be an issue with that because we said we're passed by value, right? That only happens locally. And then the p, whatever's passed in, it's not going to change after the fact. It's not going to change when you're done running a static method. But then remember this get item dunder. So we talked about this a number of times in some previous videos, but get item of use. So we have to usually pass an input into it that allows you to treat an instance of a class as a dictionary that you could stick a key into and get a value out of. So you could have an assertion, you could assert, you could throw runtime error if u is not equal to the string my val. So presumably we're only going to be able to get the value out of the dictionary associated with a key, like the key string my value, right? But you would just say return self.myval. What's the my val associated with that particular instance? But you're only allowed to pass my val into the square bracket. So hopefully that's clear to you. And then static method define increment me of p. So this was one of the solutions that we talked about for the pass by value phenomenon, is you use an instance variable rather than just some naked variable hanging out on its own. But you say p.myval plus equals 1. And it's okay to use the strongly private instance variable here because we're still in the pass by value class. And that's where the strongly private instance variable is defined, right? Since we're in it, it's not an issue to use it. The only issue is when we're outside of the class. But you would just say p.myval plus equals 1, and that will work better than this loser increment method that we talked about a minute ago. And then you could also go ahead and say return increment. So the second solution we have, if you don't want to use an instance variable of a class, is you could just return a new variable. So instead of just saying p plus equals 1, you could say return increment of p and then return p plus 1. Again, if you were a good software engineer, you would have descriptive doc strings for each of the methods, right? I think I had an example of that in the previous video, but you do want to have doc strings underneath the function header that describes what the function does, what the function accepts, and what the function returns. But define return increment of p, return p plus 1. So that would work better than this loser increment method. And then you could also say define increment list of p of 0 plus equals 1. So if you use a list of one element, that works better than just using a variable hanging out on its own, right? And then you could also make this class callable. So you could say, what does it mean to treat an instance of the pass by value class as a function? So here we'll pass in an arbitrary number of inputs to that instance of the class, right? Now we're treating an instance of a class as a function, and we'll have like parentheses. And remember with the star b, that's called a positional argument. So that allows us to pass in any number of arguments, and those arguments are treated as a tuple. And presumably this needs to be a tuple where the element at index position 2 needs to be a Boolean, because it says return b of 2 or false. So that means b of 2 either needs to be true or false. Doesn't really matter what's at b of 0 or b of 1, but you need to pass in, I guess, at least 3 elements. And the third one has to be a Boolean. So you could say print a colon equals 8. So then that would just give you 8, right? But then if you say pass by value dot loser increment of a, and then print a, remember it just says a again, because even though we tried incrementing 8 to 9, that only happens locally, and then it still says 8 after the static method is done running. So that's not what we want. So then in the first solution, you could say b equals pass by value of a. So you would just have 8 for the myval instance variable for b. And then you say pass by value dot increment me of b. All right. And then so then remember increment me. So we pass in. So we just pass in an instance. It looks like an instance of the pass by value class, and we increment the myval instance variable for that particular instance of the pass by value class. And so then that would just increment 8 to 9 successfully. If you're doing it with an instance variable, that works better than this 8 thing here, right? But you would say b equals pass by value of a, pass by value dot increment b of b, and then this is the step that takes that would take the myval of b from 8 to 9. So if you say print b dot myval, instead of getting 8, you would get 9, right? And then you could also say print b of myval. So this was using the get item dunder, right? Well, this was using the get item dunder, or the get item magic method. But print b of myval now will give you 9 again, right? It's just a different way of doing the same thing. And then print b of false, 19 true. So this is treating the instance b of the pass by value class as though it were a function that we could pass inputs into. So b of false, 19 and true. And so according to this magic method, it returns b of 2 or false. So what's b of 2 for this particular run? Well, b of 2 would be true. So true or false is true, right? That's the Boolean logic that we were talking about at the beginning. And then print a. So a is still 8. Remember, a was not successfully updated when we called the loser increment method on it. So a is still 8. So we just say print a, just to remind ourselves of that. But then if we say print pass by value dot return increment of a. So this was the second solution that we have for getting around this pass by value phenomenon. So then the 8 becomes a 9, right? Because then if we return something, if we return p plus 1, then we successfully get this 9 printed on the console. So hopefully that's clear to you. And then we could say print my list colon equal. So then you have to understand the notation here. So I have parentheses to say my list colon equals, and then the list just with a in it, just with 8 in it, right? Because a is still not changed. We returned 9, but a itself is still 8. So my list colon equals just list with just a in it, and then of 0. So at index position 0, well, then you would just have 8, right? Because the list just has the element 8 in it. And then pass by value dot increment lists of my list, right? And so then we just said, remember, like p of 0 plus equals 1. That's right here. And then so then if you go ahead and say print my list of 0, then successfully it goes from 8 to 9. So those are the 3 solutions that we talked about for getting over the pass by value phenomenon, which was leading to some weird results where the 8 here was not incremented to 9. It stayed as 8. So again, hex of x. So here's what we can do with my hex. We can review hexadecimal numbers a little bit, but what you have to understand, one of the things that we didn't talk about in lesson 68 or 69 or 70, which we should, or 71, is that hex of x technically returns a string. So it's straightforward to go from hex of int, right? It's straightforward to pass an int into hex and get a hexadecimal representation of it. But if you want to get an integer a decimal integer representation, a base 10 representation of a hexadecimal number, it's not good enough to do int of that hex. You have to do int of a val of hex of x. So one of the things we talked about is that a val of x, it accepts a string x, and it gives you the literal representation of what's being held inside of the double quotes. And that's what you have to do when you use hex of x, because hex of x returns a string. And so if you want the actual hexadecimal number, the literal hexadecimal number, you have to say a val of hex of x, and that would actually convert it to a hex. But anyway, what we're going to do is we're going to say print my hex of 151. And again, we said that all hexadecimal numbers will come out as 0x. This would be like 9 times 16, which is 144. plus 7 times 1, which is 7. 144 plus 7 is 151. And then my hex of 167. So the only difference here is instead of having the 9, we have the A, but it would just be another multiple of 16. So instead of 16 times 9 plus 1 times 7, it would be 16 times 10 plus 1 times 7. And then print of a val of my hex of 212. So again, the hex of x technically returns a string. It looks like a hexadecimal number, but it returns a string. And we can test that theory out. We could just go ahead and try concatenating a string on with like a hex, and we could see if that works out. And hopefully it wouldn't give us a type error or anything. But it says print int of a val of my hex of 212. So presumably, int of a val of hex of x. Well, hex of x accepts an int and returns a hex. Well, I guess a string representation of a hex. And then a val accepts a string representation of a hex and returns the actual hex value and gives you the integer that you started with. So that would be 212. And then print int of 0x4fa. So that would be what? That would be 4 times 256, right? Because that would be another power of 16. But 256 times 4, what is that? 1024. And then plus f. So f corresponds to 15. So 15 times 16 is 240. So 1024 plus 240 is 1264. And then a is 10, right? So 1264 plus 10 is 1274. So hopefully that makes sense to see why we got that. And then print string of 0x3e with apples. So that would be 62 apples. 16 times 3 plus 14 times 1 plus 1 times 14, I should say, is 62. So 62 apples, right? And then we can do an exploration of characters, right? So for k equals map of my character with 84, 82, 80, 78, 76, right? And then so then if we just say print k, remember map of function iterable is a generator. It doesn't return an iterable. It just returns a map object. And we said when we work with generators, you either have to preferably use it in a for loop, right? For w in that generator, right? That's the best way to use it. But also technically, you could just flat out convert it to a list or tuple or set or dictionary or frozen set, right? So you could just say print that map object. It just says map object at some memory address, right? But then if you say for s and k, for s in map of my character with these character encodings, we'll get those characters, right? We'll get the characters whose encodings are the elements in this list. So you get T for 84, R for 82, P for 80, N for 78, and L for 76. You can try some out on your own. And then we could also go ahead and do ASCII exploration. So what if we want to accept characters and get the character encoding? So you could say print list of map of my ASCII with this tuple of characters, right? And so you could say, so what does map of function iterable do? So again, it accepts a function in iterable and it yields the values of the function applied to each of the elements of the iterable. So remember my ASCII, that was just that we had a function reference variable. So my ASCII points to the ORD function. Okay, so it says print list of map of my ASCII. So it would basically give you a list with the ORD of x for each of these characters, right? So what's the character encoding of the $? 36. What's the character encoding of capital C? 67. What's the character encoding of capital I? 73. It's 6 letters further down the alphabet. So hopefully that's clear to you. But it's a generator, so that's why we convert it to a list or use it in a for loop or convert it to a tuple or set or frozen set. Print zip exploration. So now we're here. I just have some markers in the code. So B1 equals cookies, false, 82, 5.7. B2 equals 89, 88, true, and summer. And then generator max equals lambda mn, zip of mn. So it's basically a lambda function for the zip generator function. So if you just say print generator max of B1 and B2, it would basically say zip object, right? So then that's not very helpful. So you say for u in generator max of B1 and B2, print u, and it would just give you those tuples, right? We said it returns tuples where the elements are lined up. So cookies is lined up with 89, false is lined up with 88, and so on. And then my index positions is lists of range of length of B1. Enumerate 1 is lambda P, enumerate of P. And enumerate 2 is lambda Q, zip of lists of range of length of Q with Q. We said in lessons 69 and 70 that these are actually equivalent, right? If you do enumerate of P, that's the same thing as zip of lists of range of length of P with P, right? But you would say print with enumerate of X. You could say for sprite and enumerate 1 of B1, print sprite, and then you would just get 0 with cookies, 1 with false, 2 with 82, 3 with 5.7. But then if you say then with zip of lists of range of length of X with X, you could say for Pepsi and enumerate 2 of B1, print Pepsi, and then you would get the same thing. It's the same result, but doing it in a different way. And then we talked about shorthand with sets. So then if we go ahead and do set 1 is the set 9 true, set 2 is the frozen set 9 false. So if you do set 1 dot intersection of set 2, you would just get 9, right? Because you're calling it on a regular set. But if you say print set 2 and set 1, this is shorthand for intersection. And since the first set that you called was a frozen set, that's why you get a frozen set return. So that's why it just says frozen set of 9. And then you could see a similar operation for union. So again, intersection returns the collection of elements in both of the sets. Union returns the collection of elements in either of the two sets. But you could see how that works for regular sets and frozen sets. It just depends on what the first set is. That's what's going to be returned by intersection of union, intersection or union. But use a vertical bar for union, shorthand for union, and an ampersand sign as shorthand for intersection. Okay. And then we could say try. So then try in my dictionary. And then again, we said dictionaries cannot have mutable keys. The keys have to be immutable, like tuples or frozen sets or frozen dictionaries, not lists or sets or dictionaries. So you could say my dictionary equals, and then we try to assign a list as a key and then a set as a key, and then print my dictionary of 9.3, but then we'll get a type error. And that's why we print can't have mutable keys in a dictionary, right? And then we can have other examples of that too, right? So you could say current dictionary, and then you could correct it, right? So you could have a tuple and a frozen set as the keys, right? And then you could say for basketball and current dictionary dot keys, print current dictionary of basketball, and then that would basically give you 8, 9 as the first value, and then just 1 as the second value. I guess maybe because the true was converted into a 1 as some kind of an implicit cast or something. But hopefully that's clear to you. And then we talked a little bit more about iterables. The last thing I want to say in this last video is you have to think of iter of x. You have to think of iter of x as a generator. So again, if you pass in x, if you pass in some iterable, like a list or a tuple or a set or a frozen set into iter of x, basically there's another method called next of x, and it will return the elements like iterated over in the iterable. So anyway, we're just going to see a little example here. So we say my iterable, and then we have this tuple, 9, 2, true, sun, pizza. And then we have print iter of x as a generator, right? So then if you just say print iter of my iterable, you just get tuple iterator objects. And that's not very helpful. But the point, you have to think of iter of x as a generator. You either have to convert it to an iterable, to a data structure, or preferably use it in a for loop, right? So we can do both here. So you can say generators can be converted to a list, set, tuple, dictionary, or frozen set. So print list of iter of my iterable. So then you would just get 9, 2, true, sun, pizza. It would just give you a list with the elements in the iterable. Right, and then you can also say generators can be iterated over in a for loop. So you could say for s in iter of my iterable, print s, then you would just get 9, 2, true, sun, pizza on different lines, right? And then you could say k equals length of my iterable, fresh iterator equals iter of my iterable, bottle equals range of k. So if you just say print bottle, again, range of k is an example of a generator. It doesn't return a list or tuple, it doesn't return an iterable, but it can be iterated over. So if you just say print bottle, it just gets range of 0, 5. We talked about that in lesson 13, and then we talked more about generators in more detail in later videos. But then if you say for cap and bottle, print next of fresh iterators. So we talked about this next method, right? You could call next like on the iterator. You pass in the iterator, it gives you the next element in the iterable that the iterator is based on. So hopefully this gave you a good opportunity to see some more concise set notation, to see immutable keys in a dictionary, to see iter of x as a generator, and then also to review pass by value. From Umozo3, thanks for watching, and please subscribe.